Imagine a human-made base 4.5 billion kilometers from the sun, so far that even light takes 4 hours to arrive. This is Neptune, the last giant of the solar system, a world of ice. Surface temperatures drop below -220 degrees Celsius, and winds tear across the atmosphere at 2,100 kilometers per hour. And right in the middle of this hellish cold, we're about to imagine building a base. But is this actually possible, or just science fiction? From an engineering standpoint, the answer is more complicated than you'd think. Because building a base at Neptune isn't just imagination, it's negotiating with the laws of physics. Let's build this base from scratch, using real engineering logic. First, Neptune has no solid surface. Most of the planet is a dense atmosphere of hydrogen, helium, and methane. So instead of looking for solid ground to build on, we need to learn how to hang suspended in the sky. That makes our first decision clear. The base won't sit on the planet, it will orbit around it. Neptune has 14 known moons, the largest of which is Triton. Strangely, Triton orbits in the opposite direction to the planet's rotation, which makes it geologically active. This active nature makes Triton both a danger and an opportunity for our base. Because the ice sheets on its surface could become a future source of water and oxygen. That's why it makes sense to place our base in an orbit close to Triton. Being this far from the sun brings a massive problem, a near total lack of light and energy. Only about 1,000th of the sunlight we get on Earth reaches this far. Which means solar panels are useless here. We need a completely different power source. So here's what our base looks like. A massive ring-shaped structure spinning in orbit just outside Neptune's upper atmosphere. We didn't choose this ring shape by accident. A spinning ring generates artificial gravity through centrifugal force. That means the crew inside can live for years without their bones and muscles wasting away. The ring's outer surface is covered in multiple layers of armor. This armor protects against both extreme cold and cosmic radiation. The inner layer is made of a specialized ceramic metal composite for heat insulation. The outer layer is a flexible material designed to absorb micrometeorite impacts. At the center of the base sits a fixed, non-rotating core module. Ships dock here because docking with a spinning structure is nearly impossible. Long connecting spokes carry the crew between the central core and the outer ring. This design is actually inspired by real concept studies from NASA. With no sunlight available, the heart of our base has to be nuclear. A small fusion reactor can meet the entire energy needs of the station. This reactor generates enormous energy by fusing hydrogen isotopes. As backup, we also equip the base with radioisotope thermoelectric generators. These generators are a far more advanced version of the ones used on the Voyager probes. Power is distributed to every part of the ring through a network of cables. Heat management is a whole separate engineering challenge here. Because in space, getting rid of heat is harder than generating it. That's why massive radiator panels extend from the outside of the base. These panels release the reactor's excess heat into space, keeping the whole system cool. So what does daily life look like for the people living on this base? The interior of the ring is divided into agricultural modules, living quarters, and laboratories. One of the most critical sections is the closed-loop farming system. Here, LED lighting takes over the job the sun can't do. Water is continuously recycled, not a single drop goes to waste. Even the oxygen we breathe is regenerated from waste carbon dioxide. Crew members are required to spend a set number of hours exercising every day. Because even with artificial gravity, preventing muscle and bone loss is essential. The base is staffed by a crew of roughly 40 to 60 people. Most of them are engineers, biologists, and astrophysicists. Missions typically last between 2 and 3 years. Because even the return journey to Earth alone can take years. That's why the base has to be more than a workplace, it has to be a real home. It even includes a small library, a communal dining area, and an observation deck. From this observation deck, Neptune's storms can be watched for hours on end. On some nights, Triton's icy surface can even be seen with the naked eye. But this base is far from a perfect paradise. One of the biggest dangers is radiation storms. Neptune's magnetic field behaves very differently and far less predictably than Earth's. That keeps the base's protection systems constantly on alert. The second major risk is equipment failure. This far out, waiting for replacement parts could take years. That's why the base is equipped with systems that can repair themselves. 3D printers can manufacture replacement parts on demand. Psychological strain is no small matter either. This level of isolation takes a toll on the human mind. That's why the base includes regular video links and even virtual reality relaxation rooms. So, is any of this actually possible with today's technology? No, not yet. But advances in fusion energy, autonomous manufacturing, and long-duration life support systems could make this possible within decades. And maybe one day, a spinning ring in Neptune's stormy sky really will become humanity's most distant outpost. This isn't just a science fiction daydream. It's a map of just how far humanity is willing to push its limits. So, would you be ready to live on a base like this?